Today we're going to look at lesson 10.9. Lesson 10.9 is all about arc length. So we're going to determine the length of an arc today. To help us do that, we'll need to review what circumference is. Remember, circumference is basically perimeter of a circle. There's two different ways for you to think about this. Circumference is taking pi times diameter. However, remember, diameter has a relationship with a radius. If you double the radius, you get the diameter. So another way to think about circumference is 2 times pi times your radius. So say I gave you the perimeter of a square to be 12 centimeters, and I want to know what will we do to find the length of one side. So think about that for a second. Say I had this four-sided figure. So once again, in order for me to know that it's a square, couple things. We have to know that we have at least a right angle, but also with a square, all four sides are congruent. So if perimeter means that all the sides add up, and I'm telling you that it's 12, because all four sides are the same length, hopefully our thought process is, okay, if I take my perimeter and divide it by the four congruent pieces, we'll find out that each length has to be 3 centimeters. So we're going to apply that same thought process when finding the length of an arc. Essentially, I need to know, okay, if I'm given the whole perimeter, what is the fractional piece of it? And that's going to help me find the length. So we have a theorem to help us with this. It says the length of an arc is equal to the circumference of its circles times the fractional part of the circle determined by the arc. So we have a particular formula for this. Length of the arc, PQ. So I just made up that arc, but notice that once again, if you have circle, an arc is going to be where, okay, here's point P, here's point Q. We are given this arc of PQ. So if I want to find the length of it, there is a formula. What I want to do is I need to know what the measure of that arc is. Remember, we measure arcs with degrees. So as long as I know what the degree measure is, I'm going to put it over 360. Well, where'd 360 come from? Remember, there's 360 degrees in a circle. So by dividing those degrees, it gets us the fractional piece of the whole entire circle. Notice how pi times diameter, well, that is circumference. So once again, it's a fractional part of the circumference, and that's going to get us the length of the arc. Let's look at this first example. It says, let's find the radius of a circle whose circumference is 50 pi. Remember, if we're talking circumference, there's two different formulas that you can look at. You've got pi times diameter, or you've got 2 times pi times the radius. The fact is, I want to find what the radius is, so maybe using the second formula, 2 times pi times radius, is going to be more beneficial to us here. Since I know that my circumference equals 50 pi, I can replace C with the formula for what C is, which is 2 times pi times the radius. If my goal is to solve for R, what I have to do is I'm going to have to divide both sides by 2 pi. Notice that will give me the R by itself. 50 divided by 2 is going to be 25, and notice pi divided by pi is going to cancel out completely, and so the radius of the circle is 25. Let's talk about using that formula. I want to find the length of each arc of a circle with a 12 centimeter radius given the following measures of the arc. First, we'll deal with a 30-degree arc, and then we'll deal with 150 degrees. So remember, to find the length of an arc, I want the fractional piece of the circle, and then I want the circumference of the circle. Since 12 centimeters is representing the radius, I know that to find the circumference of this circle, it's 2 times pi times that radius. So notice that 2 times 12 gives me 24. There's still pi with it. So anytime I want circumference, I'm thinking 24 pi. So now that I have a 30-degree measure, remember that is going to go over 360. This becomes the fractional part of the circle, and that has to get multiplied by the circumference. I can type that all into my calculator. However, I would like you to leave your answer in terms of pi. So just type in the numbers, leave pi at the very end. Otherwise, if you want to think about it without using a calculator, we can just simplify down that fraction first. 30 over 360 really reduces down to a 12th. And if I'm multiplying that by 24 pi, well, a 12th of 24 is really going to be 2. So 2 pi is going to end up being the length of the arc. Now, because we're talking a radius with the centimeters for our units, I can also then have centimeters for the length of that arc. So 2 pi centimeters would be the length of that arc. Same exact thought process, but this time I want 150 degrees. So that's going to go over 360, but the circle's still the same. It's 12 centimeters, which means that pi times 24 or 24 pi is the circumference of the circle. Once again, you can type it into your calculator all at once, leave it in terms of pi, or we can simplify. 150 over 360 really reduces down to 5/12. And since that's being multiplied by 24 pi, notice that you can multiply the 24 and the 5 together and then divide it by 12. Or looking back at our last problem, a 12th of 24 is 2. So then 2 times 5 would get us that final length. So that's 10 pi. Once again, our units are centimeters. Sometimes I might ask you to find the perimeter of a figure. Notice that this figure is not just dealing with a circle, but it's also dealing with this quadrilateral right below it. Anytime you have multiple figures being connected, the perimeter will not include the sides that are connecting the shapes together. Notice that in the diagram, one of the lengths of the sides is 4, but I've got a bunch of congruent pieces. So that means all of those sides are 4. Those are the only sides that are going to be a part of the overall perimeter. Once again, this is technically going to be 4 as well because we do have a square. We've got a right angle, so I knew it had to be at least a rectangle. And with 3 out of the 4 sides being all congruent, that fourth side has to be congruent because opposite sides are congruent. Notice then that because that side is 4, that really then is the diameter of the partial circle that I have. Notice that because I have that diameter here, I really have a semicircle. So because we're dealing with a semicircle, remember, a semicircle is 180 degrees. So that is what's going to go over 360 to help me find that fractional part of the circle. I want the circumference of the circle, so pi times my diameter, which is 4, is going to finish out that to find the arc length. Well, because we're talking semicircle, this is going to reduce down to a half. Well, a half of 4 pi is going to be 2 pi. So that's the length of the arc. Once again, I do not want to include all 4 sides of that square. The only sides I include are the sides that are not connected. There are 3 of them. When I add those pieces together, we get 12. So combine those 2 pieces, 2 pi plus 12. Those cannot be combined any further. They're not like terms. This would be the perimeter of my figure. Notice that this figure contains a triangle as well as a portion of our circle. Once again, notice that the markings show that if that side is 10, so is this side. I'm giving you the radius of that circle to be 5. Well, notice that if that's the radius, all radii are congruent, so that has to be 5 as well. To find the length of that arc, well, notice that once again, because I basically have given you the diameter, I have given you a semicircle, which is 180 degrees. So once again, 180 over 360 gets multiplied by the circumference, which is pi times the diameter. I'm sorry, not 5, that's my radius. My diameter is 10. Once again, taking that fraction, I can reduce it down to a half. That's being multiplied by 10 times 5. 10 times pi, so half of 10 is 5. 5 pi is the length of the arc. Only 2 sides of the triangle are not connected to that semicircle, so 10 plus 10 is going to help me out with the perimeter here. That would give me 20. Combining those 2 pieces, 5 pi plus 20, those are not like terms, so this would end up being the perimeter of the figure. So this is us determining the length of an arc.